Foam is a gas dispersed in a liquid. It has a dispersed phase, and the dispersed phase is always a gas. Forms are classified into two based upon the dispersing medium. If the dispersing medium is a liquid, then it is called a liquid form. If the dispersing medium is solid, we call it as solid form. Solid forms can be prepared by freezing of liquid forms. There are two types of solid forms, dilute forms and concentrated forms. The dilute forms are kinetically unstable, and therefore, when we refer to forms, we usually mean concentrated forms. In most forms, the volume of gas will be very large, and there will be thin films of liquid or solid separating the regions of gas. And they are firmly pressed against one another, and they are separated only by thin layers of the dispersing medium. If the dispersing medium is liquid, then they will be separated by a thin layer of liquid. If it is a solid form, then the thin layer will be a solid, and we call this thin layer as a foam film. Examples of forms include a bath sponge, the head on a glass of beer, blowing soap bubbles, and injecting air into frothing solution. Solid forms are divided into two: closed cell forms and open cell forms. In a closed cell form, the gas forms discrete pockets, and each of these pockets will be surrounded by a solid material. The gas pockets are sealed from one another, and there is no connection between them. Examples include a camping mat. The second type, called the open cell solid forms, contains gas pockets, and they are connected with each other, as you can see in the figure. Since there is connection between them, the dispersed phase, that is the gas, can easily flow through the entire structure, displacing the air. Now let's see how forms are produced. Forms can be easily produced by dispersion methods, like forcing the gases through a narrow capillary into a liquid. The best example is forming bubbles through soapy water through a straw or a pipe. Another method is intensive agitation of the liquids in the presence of gas using mechanical stirrers like this. The simple examples, or the common example that you usually see, is whipping of creams or preparing cocktails. Foams can be obtained by condensation method. As you know, during a condensation reaction, small molecules will be eliminated, and these will be usually gases. So the condensation method will result in the formation of gaseous products or the evolution of a gas dissolved in a liquid. Now let's see the properties of forms. Forms are characterized by some features or indices like their dispersion. Dispersion means the mean diameter of the gas bubbles. As you know, different bubbles will have different diameters. Some will be small, some will be large. So we are taking the mean diameter of the gas bubbles, and that is called dispersion. The second index is the height of a form column, and this is determined by blowing the gas through the liquid in a cylinder of a standard size. Third is the lifetime of an individual foam bubble. And the last one is called the foam multiplicity. Foam multiplicity is represented by the symbol beta. It is defined as the ratio of the foam volume to the volume of the liquid from which the foam was formed. So beta is equal to Vf by V liquid, where V liquid represents the volume of the liquid and Vf represents the foam volume. Now the value of beta can vary. If beta is less than 10, we call the form as a wet form, and if beta is much greater than 1000, we call it as dry form. The form stability occurs due to two factors: van der Waals forces between the molecules in the form, and also the electrical double layers created by the presence of surfactants. But forms are the most unstable variety of all the dispersed systems like emulsions, aerosols, etc. Because, as you know, a form will not last for long. Say soap bubbles, it will burst after some time, within a few seconds. So in the course of time, the films, the thin films between the foam bubbles will become thinner as the liquid runs off, and finally it will burst off. The bubbles will burst, leading to the destruction of foam. Foam stability can be characterized by its lifetime. Lifetime means the time from the formation of the bubble to the complete destruction of the bubble. Lifetime varies from a few seconds to maybe a few days. The lifetime will depend on the viscosity of the dispersing medium, nature of the solute, and also their concentration. As you know, a soap solution can form bubbles, but water alone cannot form bubbles, which means absolutely pure liquids cannot form forms. And even if they form such forms, the lifetime of such forms will be negligibly small. Aqueous solutions of alcohols and fatty acids can form slightly stable forms. Soap is an example which produces stable forms because of its ability to produce ions. Now it is found that the most stable forms are formed when the concentration of the alcohol or acid is very low. The stability of a form depends on the nature and concentration of the forming agent and the hydration of the forming agent. Hydration is a factor which slows down the flow of liquid in the form, preventing it from breaking, and also it is a reason for form. To form a stable form, the liquid film should be able to change its surface tension very rapidly. Also, it must be able to withstand local deformation without rupture. That is, if it undergoes some kind of stress or strain, it should be able to withstand it. A stable form must be able to increase the surface tension upon local strains like this and decrease it upon local compression. Now let's see forming agents, which are also called form stabilizers. Forming agents are substances in whose presence the lifetime of a form can be prolonged. And good forming agents are usually substances which can lower surface tension. which means examples of forming agents include soap, proteins, detergents, polymers, etc. Now these are such good forming agents that mere shaking of these materials with water itself will be sufficient to produce forms. Forming agents are of two types. The first one is not much effective as a forming agent because when the concentration of the forming agent in the system grows, the lifetime of the form rapidly reaches a maximum. With further increase in the concentration of the forming agent, the lifetime begins to shorten. Examples of such forming agents include the lower members of the homologous series of fatty acids and alcohols and alkalis. The second type of forming agent includes substances that continuously improve the stability of a form when the concentration in the system is increased. Such substances also have a detergent effect and are called detergents. And these include salts of higher fatty acids, that is SOPs, alkyl sulfates, alkyl sulfonates, alkyl aryl sulfonates, and some high molecular compounds like gelatin. Next, anti-forming agents. Forms can be destroyed by using anti-forming agents. Anti-forming agents are more active than the forming agents, so they will eventually displace the forming agents. Examples include octyl and amyl alcohols, cyclohexanol, esters, ethers, and silicon oils. In addition to using forming agents to destroy forms, you can also give a thermal or mechanical action on the forms to destroy them. What are the applications of forming agents? You have studied in your lower classes about Froth flotation process that is used in the concentration of minerals by Froth flotation. It is also used in laundering and washing, in the production of highly porous building and insulating materials like formed concrete and formed glass. Also, in the production of plastic forms. Forms formed from lather of shaving soap lowers the flexibility of hair and increases the ease with which it can be cut. Forms are also used in fire extinguishers, and the bubbles of carbon dioxide stabilized by glue are called fire foam. Foam formation is also used to separate the components in a mixture, say for example a mixture of bile acids.